For our last video, video number 3 on balancing equations, we're going to look at, again, compounds that are a little more complex. So if you look down at the examples here, I have an A and B. You're going to see there's a little bit more going on in each equation. And what hopefully will jump out to you is in A is we now have parentheses. So we have these polyatomic ions, and we're going to look at balancing them as a group. So if there are polyatomic ions that remain together as a group, and that is the key, count the polyatomic ion as a unit and count the number of the group, not the number of the individual atoms. So the remain together as a group, as I said, is key, so we need to look at examples A and B. So here you have PO4 as a group. Do you see PO4 as a group over here? Now there's an H with this, but you still can see PO4 is together. Hopefully by now you recognize some of these from writing the formula. So there's SO4 on this group and SO4 on this group. When we come down here to B, so I have just single elements here. Here I have 3, so there's going to be a group. So CO3 is a group, but if you come over here, there's no CO3. This is CO2, so it's not exactly the same, so I can't count this one as a group. So we're going to see that in letter B. So I'm going to go back to the reactant product table, and again, if you don't need that, that's fine, but I'm going to start this just so you see this for this new concept. So I'm going to do calcium, I'm going to do PO4 as a group. Hydrogen is not a polyatomic ion, so even though there's 2's on both sides, it's not a polyatomic ion, it's not listed as a group on the back of your pink sheet or your ion chart, so I'm not going to keep that together as a group. But SO4 is a group, and I do see it on both sides of the equation, so we'll see that even though this looks really complicated, I still only have 4 things to balance. So I'm going to go through and do my atom inventory. So calcium's the same, I have 3. Here's why parentheses were so important. So this 2 that I have on PO4, this 2 is 2 of this entire group. So I have 2 PO4 groups, I have 2 hydrogens, and no parentheses means I have 1. So that might be something you want to write down. So no parentheses equals 1 of a group. Okay. Product side, I'm going to come back and look for calcium on this side. So again, this is another one like we did in the last video. Calcium's in 2 different places, so I'm going to do 1 plus 1, give myself some room. PO4s, so I'm going to kind of chop this in half. So I have this PO4 group that also has 2. So you're probably liking the way that looks already. Okay. Hydrogens, I have to be careful. So parentheses are a distributive property here, but we're just kind of working backwards in chem. So I have hydrogen, oops, 2 times 2 for a total of 4. So again, Ca H2PO4 taken twice, 2 distributes to this group and 2 distributes to that. So that's where this is coming from. Okay, so again, if you don't want to do 2 times 2, you can just start with writing 4, and that might be less confusing when you are looking at am I putting any coefficients in or not, but that's where that comes from, so that's why I wanted to put that out there. And then SO4, again, there's no parentheses, so I'm going to do 1. So calcium's not balanced, but because it's 2 different places, I don't want to start with that. So PO4 is balanced, hydrogen is not. So I'm going to start with the hydrogen. I need a multiplier of 2 to get 4 on the reactant side. Since this is a true multiplier, so this 2 wasn't anywhere to be found in the equation or the formula before, that 2 is going to become my multiplier up here. So 2 times this 2 is going to give me my 4 here, but then that 2 also distributes to sulfate. So I have 2 of that entire group now. So it's like writing 2 SO4 this way. So now my sulfates are not balanced, so I'm going to multiply by 2 here to get 2 sulfates. Okay, I'm going to put my multiplier on the product side in front of the formula that has sulfate in it. Okay, that's going to change my calcium. So this is the second calcium. So this calcium goes with this calcium goes with this calcium. So this is times 2. So really this whole thing is 2. I really have 1 plus 2, which is 3, and my equation is now balanced. So it looks really complicated, but it really, if you balance them as groups, it's not too bad if that's possible. Okay, in B, with our reactant product table, we have no choice but to balance each element separately. So there's no CO3 group over here, so I'm just going to be looking at each one individually. So I have 1 hydrogen, 1 chlorine, 1 calcium, 1 carbon, and 3 oxygens. On the product side, I'm going to do 2 hydrogens, 2 chlorines, 1 calcium, 1 carbon, and 2 plus 1 oxygens. So you'll see the only thing that isn't balanced is hydrogen and chlorine. So I need a multiplier of 2 for my hydrogen. Okay, put that coefficient in. That 2 distributes to not only hydrogen but also chlorine. And at this point I'm balanced. 2 and 2 for each of these. 1 and 1, 1 and 1. 2 plus 1 does add up to 3, so I have 3 and 3. Pretty basic equation, even though it looks like there's a lot to it. Now there's a little trick of the trade that I'm going to show you with the next formula. Sorry, I'm adjusting my camera here. I'm trying to have this zoomed in so you can see, but I think I need to go back out so you can see the entire paper here. If water is on one side of the equation and a source of hydrogen and hydroxide are on the other, rewrite the formula of water as HOH and balance the OH as a group. So remember when we were doing diagrams with water, we were always doing that little Mickey Mouse. Okay, this is HOH. So instead of writing it H2O, it's just another way of representing water. So H and H are my 2 hydrogens, and this is my OH group. So it's kind of like lopping off one of Mickey's ears for that separate hydrogen. And we're going to keep OH together as a group. So I'm going to just write water HOH underneath the formula. If you want to cross it out, you can, but just for making this easy to read, I'm not going to cancel that out again. So I'm going to do a reactant product table and do calcium, hydrogen, and hydroxide. So I'm not counting hydrogens and oxygens separately. And again, the only reason I can do this is because I have a source of OH on this side and a source of hydrogen on this side. So I have 1 calcium, 1 hydrogen, because again, I'm only counting this part. The OH is going to be separate. So I have 1 of these and 1 of these. When I go to the other side of the equation, I have 1 calcium. This time I have 2 hydrogens because of the subscript for hydrogen, and because OH is in parentheses and I have a 2, that will balance or give me 2 hydroxides. So now it's pretty easy to balance. All I have to do is multiply hydrogen by 2. Okay, and because water is linked together, that goes to both parts. So you'll see I updated those automatically. So I have 2 hydrogens and 2 hydroxides. And that's a lot easier than trying to count it out without doing the hydrogen and hydroxide. It's not impossible to do the other way, but it is a little bit more difficult. So if we look at this without doing water HOH and we just keep counting it as individual elements, I'm going to have 1, 2, 1, calcium's 1. I have to remember to distribute through the parentheses. So I have 2 oxygens, 2 hydrogens here plus 2 here. So this is a total of 4. And again, you might not think this is any more difficult, but there will be times when this will absolutely be easier for you.